Hello, myself Sheetal Vishwakarma from MTech IIPS GAVP Indore, India. In this video, I am going to explain algorithm of naive Gauss elimination method to find value of unknowns from n equations. Gauss elimination method is a method to solve simultaneous linear equations of the form matrix A into matrix X equal to matrix C, where matrix A and matrix C are the coefficient matrix and matrix X is the matrix of unknowns. There are two steps of Gauss elimination method. First is forward elimination and second is back substitution. Forward elimination is a method to transform the coefficient matrix into an upper triangular matrix, that is, to make the triangle elements of the matrix 0, so that the calculation will be easy. If we have n set of equations with n unknowns, this will look like a11x1 plus a12x2 plus a13x3 plus dot 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 plus a1n xn equal to b1. A11, A12, A13 are the coefficients and x1, x2, x3 to xn are the unknowns. To calculate the value of x1, x2, x3, xn, we have to follow n-1 steps of forward elimination. The algorithm for triangularizing n equation in n unknowns can be given by for I equal to 1 to n in steps of 1 and j equal to 1 to n plus 1 in steps of 1, do read a, I, j and for. That is, in this for loop we will read all values of coefficients from a11 to ann. Now there is second for loop for k equal to 1 to n minus 1 in steps of 1. This is an outer for loop for which will run if there are three equations. This loop will run from 1 to 2. Now there is another for loop inside the outer for loop. This will run from I equal to k plus 1 to n in steps of 1. That is, if k equal to 1, it will run from I equal to 2 to n. If n equal to 3, it will run from 2 to 3. In this for loop, we have done u equal to aik upon akk, means setting a constant by which we have to multiply our constant equation. Now there is another for loop for j equal to k to n plus 1 in step of 1. Do aij equal to aij minus u into akj, and for this is an end of this third for, and then there is an end of second for, and finally there is an end of third for. Now let's check this algorithm with three equations with three unknowns. First, our step is step 1 for equation 2 divide equation 1 by a11 and multiply by a21. That is, here u equal to a21 upon a11. That is, we have seen previously in this for loop we have set u for I equal to k plus 1. Here I equal to 2 n equal to 3. So u equal to 2 a21 upon a11 into a11 x1 plus a12 x2 plus a13 x3 equal to b1. This can be written as a21 x1 plus a21 upon a11 into a12 x2 plus a21 upon a11 into a13 x3 equal to a21 upon a11 b1. Now subtract the result from equation 2. Equation 2 is a21 x1 plus a22 x2 plus a23 x3 equal to b2 minus a21 x1 plus a21 upon a11 into a12 into x2 plus a21 upon a11 into a13 into x3 equal to a21 upon a11 b1. So result will be, here the coefficient of x1 is turned to 0 in equation second. So equation second will be given by a22 minus a21 upon a11 into a12 whole into x2 plus a23 minus a21 upon a11 into a13 whole into x3 equal to b2 minus a21 upon a11 b1, or a22 dash x2 plus a23 dash x3 equal to b2 dash. Now for x3, that is for value of x3, multiply equation 1 by a31 and divide it by a11. So by this we can make 0 the coefficient a31. So multiplying a31 and dividing by a11 to equation 1, we will get a31x1 plus a31 upon a11 a12 into x2 plus a31 upon a11 into a13 into x3 equal to a31 upon a11 into b1. Now subtract the result from equation 3. Equation 3 can be given by a31 x1 plus a32 x2 plus a33 x3 equal to b3. Now subtracting the result which we have got, the result is a31 x1 plus a31 upon a11 into a12 into x2 plus a31 upon a11 into a13 into x3 equal to a31 upon a11 into b1. So resultant x3 equation will be the resultant third equation will be the coefficient of x1 is made 0 and the coefficient of x2 is a32 minus a31 upon a11 into a2. Coefficient of x3 equal to a33 minus a31 upon a11 equal to b3 minus a31 upon a11 into b1. So now the set of equation will look like this. In the first column we have made two zeros except the coefficient of x1, because from first equation we have to calculate value of x1 and from second equation we have to calculate value of x2 and from third equation we have to calculate value of x3. Now there is an end of step 1. Now repeat the same procedure for the third term of equation 3. Now for equation 3 we have to make 0 the coefficient of x2 in equation 3, for which we have to multiply equation 2 by a32 and divide it by a22 and subtract the result from equation 3. We will get following result, that is equation 1.3. Now this is the end of step 2. As we have seen that to solve the equation we need two steps. So to solve n equation we will need n minus 1 forward elimination steps. The system of equation will look like a11 x1 plus a12 x2 plus a13 x3 plus dot 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 plus a1 and xn equal to b1. Then second equation will be reduced to a22 x2 plus a23 x3 plus dot 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 a2 and xn equal to b2. Third equation will be reduced to a33 x3 plus dot 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 plus a3 and xn equal to b3, and nth equation can be given by a and xn equal to bn. Now this is the end of step n minus 1. Now the final matrix will look like this. In this we have made the upper triangle to 0 using the triangularization algorithm. Now we will follow back substitution. Back substitution will start using these equations. Back substitution means to evaluate first to evaluate xn and use it to evaluate xn minus 1, and using xn minus 1 we can evaluate xn minus 2. The algorithm of back substitution can be given by xn equal to bn upon an, as we have seen earlier, for I equal to n minus 1 to 1 in steps of minus 1. That is from lower equation to upper equation we will move. Then we have initialized sum equal to 0. What is sum we will see with with an example. For I for j equal to I plus 1 to n in steps of 1, do sum equal to sum plus aij xj. This is the end of for loop. Then xi equal to ai n plus 1 minus sum upon a11. Then there is an end of another for loop. Now let's check back substitution with the three equations which we have got using forward eliminations of n equations. These are the three equation 1.1, 1.2 and 1.3. These are the equation a11x1 plus a12x2 plus a13x3 equal to b1. A second equation is a22x2 plus a23x3 equal to b2, and third equation is a33x3 equal to b3. Now values of x3, x2 and x1 can be calculated using these equations. x3 equal to a34 upon a33, x2 equal to a24 minus a23 into x3 upon a22, x1 is a14 minus a12 x2 minus a13 x3 divided by a11. As we have talked about sum, in this if we look at x1, a12 x2 plus a13 x3 is the value of sum for x1. So for n equations we will get n minus 1 term, addition of n minus 1 terms in sum. So using back substitution we can calculate value of x3, x2 and x1. Using x3, x2 can be calculated as we have seen, and using x2 and x3, x1 can be calculated, because x1 equal to a14 minus a12 into x2 minus a13 into x3 upon a11. So here in x1, x2 and x3 are used, which we have calculated earlier. So we can find value of x1. Hence, using Gauss elimination, we can solve for n values of x. So thanks for watching this video.